Alright, so we're going to talk a little bit today about an intro to algebra. So I think you guys have been doing something very similar to this. You maybe just did not know that you were doing algebra. So the first thing I see up here on slide 1 is that I have a triangle which equals 4, a rectangle that equals 2, and a circle that equals 5. So knowing that information, I can go down here and I can solve the rectangle times the circle. Just plug these values in. So 2 times 5 is 10. I now have a triangle plus a rectangle, so I can do 4 plus 2, which is 6. Periodically, I will ask you to write things in your notebook, so make sure you have your notebook out. This is not one of those times. I think you guys can probably do this mentally. Alright, the next page, if I can figure out how to move over there. Okay, so again, very similar. Now I have a 4, a 2, and a 5, so order of operations. In this case, I have addition and subtraction, so I'll just work from left to right. My rectangle is 2, so that's essentially 2 plus 5, which is 7, minus 4. So 7 minus 4 is 3. And then order of operations again, I'll do multiplication first. So 4 times 2, which is 8, plus 5, which is 13. So now if I start to take away some of those shapes, I can do 3 minus what equals 1. I always ask myself when I see something I don't know, 3 minus what equals 1? Well, 3 minus 2 equals 1, so the triangle has to be 2. What times 4 equals 20? Well, I know 5 times 4 equals 20. And then 6 plus n equals 8. 6 plus what equals 8? 6 plus 2 equals 8. So algebra is just a language of symbols. Symbols can be shapes, they can be blank spots, they can be letters, and all of those things are called variables. Just quickly, let's go over some multiplication symbols because you might see this throughout your math career starting now. I've gone over some of these, but if you see a dot, that means 2 times 3. So all of these mean multiplication. If I have a number next to a variable, that also means 5 times t. 2 letters next to each other will mean s times t. Parentheses also means multiply, and if I have one outside parentheses and one inside, it also means multiply. So any of these symbols, and sometimes even on the computer, since it's kind of hard to make the dot, you might see this symbol as well, the asterisk, that also means multiply. We are going to start to get rid of the x's to mean multiply because in algebra, the most common variable we use is x. So instead of writing this symbol to mean multiplication, we are going to use one of these. Most often, it's going to be written like that. Okay, this is, oh, I'm sorry, let me go back. Please write this in your notebook too. So now in your notebook, you're going to start taking some notes. So this needs to go in your notebook. Pause if you need to, but I'm going to go to the next slide. Please put this in your notebook, that a variable is a symbol. It's usually going to be a letter, but like in the first couple of slides, they were written as shapes. But usually a letter is going to be used to represent an unknown value. So if I have 2 plus c, that means 2 plus some number that I don't know right now because I don't have an equal sign. If I have an equal sign, then I can figure out what c means. But right now, I have 2 plus some number. In this example, that's 5a, which means 5 times some number. Again, I don't know what those values are yet, and that's okay. A constant. So please, again, write this down. A number that stands alone and its value does not change. You are going to see 2 numbers here. One of these is a constant and one of these is not a constant. In this example, 5 plus 2a, this is considered a term. The value of this could change depending on what a is. Let's say a is 1. Then I would have 2 times 1. Well, that's going to be 2. A could also be 5. Well, 2 times 5 is 10. So this value can change, but this value will never change. This 5 alone will always remain a 5. In this example, I have 4 times t minus 20. Which one is a number that stands alone? Well, the 20 is a constant. That 20 will always be a 20, can never be anything else but a 20. And this value could change depending on what t is. So 20 and 5 are my constants. They stand alone. They do not change. Whereas a coefficient, again, you might want to write this down, not all of it if it's too much, but a coefficient is a number in front of a variable. So if I were taking notes, that's exactly what I write, a number in front of a variable. And then this is just something to help you remember that the prefix co means with. So if I know that I have coefficient, that literally translates to with a letter. So I am going to see a number next to a letter, that's a coefficient. So 3x, my 3 is my coefficient, 14t, 14m. The coefficient here is actually 1. If I just have m, the coefficient is 1. So if I don't have a number there, it's going to be 1. This expression, I have two coefficients. I have a 5, and again, if nothing is written there, it's presumed to be 1. I have 1s, right? If I just had an m here, well, how many m's do I have? I have 1m. We just typically don't write it. And up here, the coefficients would be 4 and 2. Those are coefficients. 5 and 20 are constants. It's an important reminder, or important distinction you need to remember. And then if we know what a coefficient, a constant, a variable is, then we know what an algebraic expression is. It's going to be a combination of three things. We need to have variables, so if it doesn't have variables, it's not an algebraic expression. We need to have numbers, and we need to have at least one operation. So all of these are algebraic expressions. All right, now on this table, I just want you to think, you don't need to write this in your notebook, but if I have 5 plus m, just in your head, think what is the variable, what numbers are being used, and what is the operation being used. It could have more than one or it could not have any, but I need to fill all three criteria for it to be an algebraic expression. So in 5 plus m, do I have a variable? Yes, I have m. Do I have numbers? Yes, I have 5. And don't forget that sneaky 1 there. So you can write 1, but I'll just leave it off. The operation here is to add. So as long as I have all three things, that's an algebraic expression. The variable here is h. Numbers, I have 6, 2, and 1, but I'm not, well, maybe I'll just write it. Don't forget we have a 1 there. The operation, I have subtraction and addition. My variables here, now I have two variables, an r and a t. My numbers, I have 7, technically a 1. I guess if I'm adding 1, I'll add it to the first one too. My operations, I have multiplication and addition. Then we're going to move into evaluating expressions. So evaluating expressions simply means to solve. Now you don't need to write this down, but I would like you to try this in your notebook. So let's evaluate each expression if w equals 5. So now we're going to plug this value in for anywhere I see a w. So if I have 6 plus w, that's 6 plus 5, which is 11. If I have 8 minus w, that's 8 minus 5, which is 3. And 2 times w, which is 2 times 5, which is 10. Okay, let's try to solve these. M plus p, so that's literally 3 plus 7, which is 10. And now I have m times p, so 3 times 7 equals 21. Okay, a couple more. Let's see if I can get this in the frame a little bit better. Okay. Now it's important to remember our order of operations. So with with addition and subtraction, we just went from left to right. So this is going to be 8 minus 2, which is 6, plus 6. So that's 12. Sometimes it can help you to rewrite it. T times k divided by r. So again, we just work left to right. I have 8 times 6, which is 48. 48 divided by 2 is 24. Okay, another one, t times k. So that's 8 times 6, which is 48, divided by 2, which is 24. I think we just did that one. And then t times k, so we have 8 times 6, which is 48. And k divided by r, so we have 6 divided by 2, which is 3. Okay, so you should see on the front table a coefficient, constant, variable, and operations packet. You are going to just basically, you'll get an expression, so like 3c minus 2. You'll tell me that the coefficient equals 3. The constant, remember that's just the number that always remains constant and will never change, equals 2. The variable is c. And the operation, we have 2 here. We're multiplying 3 times c, and we're subtracting 2. So multiplication and subtraction. That's what you're doing for the packet, and then you'll work on these pages in your textbook.